the Celera 500L from Otto Aviation impresses with its outstanding technical features as well as its extraordinary and very beautiful design. That's why we decided to build a remote-controlled model of it. And this is our model. But let's start from the beginning. First, the proportions are taken from photos on the internet as closely as possible. The scale is set at 1:11, which corresponds to a fuselage diameter of 180 millimeters and a wingspan of 1,400 millimeters. To keep the wing loading low, however, the wings are made square root of 2 longer and wider in the first attempt, which doubles the surface area. For the fuselage, a one-part master model is assembled from several slices of wood, which are then turned into the desired shape on a lathe with the aid of a template. This is possible here because the fuselage is rotationally symmetrical. Before a mold is made, the wood is covered with a thin layer of glass fiber fabric and filled and sanded several times. What follows is the usual procedure for creating 2 negative half shells, whereby the division into 2 halves is not made horizontal as usual, but vertical. The reason for this is that the load-carrying underside of the fuselage can now be produced in one continuous piece and without a predestined breaking point. In addition, the vertical split is possible on this particular aircraft because there are no rounded wing root fairings. The molding process starts with white gel coat. Colored laminating resin is then used to achieve the best possible white surface despite the carbon fibers inside. It will, however, become apparent later that additional varnish is required to make the surface really uniform. Here, the lamination scheme is shown. 2 layers of carbon in the lower half are separated in the middle area by a 2 mm thick foam core, which makes the wall so stiff that it cannot be deformed by hand. But this also makes the airplane heavier. Therefore, this sandwich principle is only used to connect the highly loaded points, i.e. landing gear, battery, motor, wing mount, and tail units. A tongue at the bottom of the fuselage is sufficient. The rest can be made thinner. The upper side in particular, because it only completes the fuselage but does not carry much weight. Due to the vertical division of the half shells, the sandwich material at the bottom can go through in one piece, and there is no weak point in the middle. Now, the excess is cut off and peel ply is applied, as well as a layer of perforated bagging film and absorber fleece. The whole piece is placed in the vacuum bag for 24 hours. The peel ply is then removed, and a few reinforcements and bearing points are added. The weight of the fuselage, including battery holder, carbon ribs, and servo boards, but without RC components, is around 500 grams. The elevator and rudder are to be made in the form of pendulum tail units. 5 mm carbon tubes connect the right and left elevator, respectively the rudder and ventral fin. This leaves very little space for the motor directly in front of the propeller. The motor is therefore selected in view of highest possible power in a small installation space. It is powered by a 4-cell LiPo battery and an 8-inch 3-blade propeller. A larger propeller would not be to scale with the original. A few more works and the plane is finished. The construction of the wings and tailplane will be explained later. The model does not have the air intakes for the diesel engine. After all, it doesn't have a diesel engine. Otto Aviation also announces that these elements will be removed once the original version is equipped with a fuel cell drive. Time for the first flight test. Will it fly straight away? Pilot Paul is confident and maneuvers to the optimal position for takeoff. The direction was not quite right, so better try again. Unfortunately, the front landing gear broke off, so we now have to launch the plane by hand.
Oh.
There are many possible reasons for the crash landing, but there are also doubts as to whether this unscientific way of building an airplane is effective. So the whole concept is first simulated in FLZ Vortex. This effort shows that in fact for reasonably good-natured flight behavior, the elevator must be 20% larger to match the large-scale wings. With this small change, everything indicates good flight behavior. In the following, the elevator is built 20% larger. The core of the elevator is cut from 30mm Styrodur using a hot wire. Because Styrodur would be too fragile, especially at the edges, edge reinforcements made of thin carbon bidiagonal fabric are used. For reasons of parsimony, the surface is not laminated entirely. This would probably also be too heavy. The fabric is held in shape by adhesive tape. For the adhesive tape to hold, the fibers underneath must remain dry in the first step. The whole part is cured in a vacuum bag for 24 hours. The next day, the adhesive is removed and the exposed fabric is bonded separately using vacuum pressure. Carbon rowings on the top and bottom serve as spars. The tail units are mounted using wound carbon tubes. The advantage over pultruded tubes is the increased torsional stiffness. Adapting all surfaces to the fuselage shape is particularly easy with this construction method, easier than with a wooden rib construction. Irrespective of the aerodynamic changes, the landing gears also need to be replaced. Here, the problem was a lack of stability or the possibility to deflect. The rear landing gear is supposed to be a stable standard one, although it will be cut a little narrower to save weight. At the front, a 2mm wire is bent by hand at first. This seems a little weak to us, so a 3mm standard aircraft undercarriage is used here too. Ready for the next flight attempt. The airplane is still hopping over the grass, but the landing gear stays intact.
Ui! Endlich! Oh, wo ist das Flugzeug? Habe ich verloren.
That looks already better. The first flight lasts exactly 6 minutes, and only 580 milliamp hours are used from the 2,200 milliamp hours battery. We are very happy with that.
Also, willst du jetzt landen? Nee. Achso, okay. Toll.
Reicht du noch? Ich kann nicht mehr.
Toll gelandet.
Welcome to Hanover. There is criticism that the sound is more like a multicopter. This is due to the multi-copter propeller used, which is optimized for low speed. An alternative propeller is sought with the help of a scale and a current clamp. The multi-copter propeller produces a particularly high static thrust, and the current matches the specifications of the motor's manufacturer well. The three-blade airplane propeller sounds better, but draws too much current and causes the whole plane to vibrate. The two-blade airplane propeller, finally, draws less current than it should, but still delivers high thrust, so it's chosen for now. The pilot is satisfied with this noise.
Schon mal ab wie eine Rakete.
About the flight behavior. Initially, the model pulls the nose up at high speed, but this problem can be solved by moving the battery 10 millimeters to the rear. Apart from that, the pilot reports that the model is easy and stable to fly. The position of the wings far back on the fuselage does not seem to be an issue. The analysis in FLZ Vortex has shown that the model jet should have very good gliding characteristics, although not quite as good as an optimized glider. The pilot assesses the gliding behavior as follows.
Das ist übelst krass, wie der segelt.
This is meant as a positive judgment. In fact, the glide performance is so good that it is difficult to land the plane on a short runway. We had actually expected the large fuselage cross-section to be a significant break. Instead, this is not a problem, and it would even be advisable to consider installing additional brakes for landing. However, we refrain from such efforts right now, because the plan is to make the wings smaller in the next version anyway, as in the original Celera. Then the large fuselage cross-section might become a problem after all. In the next version, the airplane will be built exactly to scale, i.e. with wings half the size and a smaller tailplane. For this to work, the weight will probably also have to be reduced further. We are curious to see what experiences this will bring about.
Das ist geil, das Ding. Ja, ich mag den auch.